Hello everybody, this is Naveen Sapare, Assistant Professor, Department of Mathematics, KLIT Hubli. So today we'll continue Z transform. So we'll solve some more problems. Let us solve the problem. Find the Z transform of cos n theta and sin n theta, and hence find Z transform of k raised to n into cos n theta and Z transform of k raised to n into sin n theta. So to find Z transform of cos n theta and sin n theta, what steps we are going to take here? So let I will take e raised to in theta, and since we know that e raised to in theta is nothing but cos n theta plus I sin n theta. It means in the problem we need to find Z transform of cos n theta and Z transform of sin n theta. Means in this expression we need to find out the Z transform of the real part and Z transform of the imaginary part. So we make use of this equation and we find the Z transform of cos n theta and sin n theta. So I will take Z transform on both sides. So I will write it as Z transform of cos n theta plus I sin n theta. So we will find out the Z transform of cos n theta and sin n theta together, okay, in a single problem. So obviously I am taking Z transform on both the sides. So I am taking this e raised to in theta at right hand side. So Z transform of e raised to in theta. So this is equal to Z transform of, I will write this e raised to in theta as e raised to I theta raised to n. So now we need to find the Z transform of e raised to I theta raised to n. Obviously we know that in a Z transform n will be variable and theta will be considered as a constant. Therefore e raised to I theta we will consider it as a constant, and we make use of the formula of Z transform of k raised to n. And we know that Z transform of k raised to n is nothing but z divided by z minus k. But in place of k, we are having e raised to I theta. Therefore, we have here Z transform of e raised to I theta raised to n comparing with k raised to n. We write the Z transform as z divided by z minus of e raised to I theta. So now obviously at the left hand side we are having cos n theta plus I sin n theta, and we know that cos n theta is a real part and sin n theta is a imaginary part. So now at the right hand side also we try to get the real part as well as imaginary part, so that we can equate real part and imaginary part from left hand side as well as right hand side and then get the Z transform. So how to get the real and imaginary part at the right hand side? So I am going to multiply numerator and denominator by z minus of e raised to minus I theta in the numerator as well as in the denominator. So multiplying z minus e raised to minus I theta in numerator as well as denominator. Why am I multiplying z minus e raised to minus I theta here? Just to separate real and imaginary part, to get the real and imaginary parts. So simplifying further here, so we have z into z is z square minus z into e raised to minus I theta in the numerator, divided by multiplying in the denominator also, z into z is z square. Next is minus z into e raised to minus I theta. Next minus z into e raised to plus I theta. Then multiplying these two we get plus e raised to I theta into e raised to minus I theta will be e raised to 0. So e raised to 0 will be 1. Simplifying further, so here z square as it is minus z into, and since we know that e raised to minus I theta is nothing but it is cos theta minus I sin theta, whole divided by z square minus, again from these two terms we are having minus z common, so taking it out, and inside the bracket it will be e raised to I theta plus e raised to minus I theta plus 1 here. So next is z square as it is minus multiplying z into cos theta and plus I into z into sin theta, whole divided by z square minus z into this e raised to I theta plus e raised to minus I theta can be written as, obviously it is 2 times of cos theta plus 1, because we have a formula e raised to I theta is nothing but cos theta plus I sin theta, and e raised to minus I theta is nothing but cos theta minus I sin theta. When you add e raised to I theta plus e raised to minus I theta, then definitely we get 2 times of cos theta. Now simplifying further, we have here z transform of cos n theta plus I sin n theta is equal to, now I am separating the the real part and imaginary part from the numerator. So I get here z square minus z into cos theta as a first term, and the second term I will take it as an imaginary part, that is I into z into sin theta, whole divided by, I just simplified further the denominator also, z square minus 2 times of z into cos theta plus 1. Now separating real and imaginary part here, so we have z square minus z into cos theta divided by z square minus 2z into cos theta plus 1 plus I into z into sin theta divided by z square minus 2 times of z into cos theta plus 1. So definitely here we are having z transform of cos n theta plus I sin n theta. Now equating the real part and imaginary part from left hand right side, so we have z transform of cos n theta is equal to, obviously this is the real part, this is imaginary part, so is equal to z square minus z into cos theta divided by z square minus 2z into cos theta plus 1, and also z transform of sin n theta is equal to, obviously equating real part with real part, imaginary with imaginary part. So we have z into sin theta divided by z square minus 2z cos theta plus 1, and hence we have the z transform of cos n theta as well as sin n theta. So this is the first part. Now we need to find z transform of k raised to n into cos n theta and k raised to n into sine n theta. So yesterday we studied a property z transform of k raised to n into un will be equal to u bar of z by k. There first we need to find out the z transform of un. In that answer just we replace z as z by k. So now similarly here also z transform of k raised to n, sorry, here it is obviously I'm going to write the formula first. K raised to n into un is nothing but, here we are having a formula u bar of z by k. So this is a property where first we find the z transform of un, later in that answer we replace z as z by k. So now therefore z transform of k raised to n into, it is cos n theta. So it means that here un is nothing but cos n theta. So first we need to find out the z transform of cos n theta, and already we are having z transform of cos n theta. So now our work is just to replace z as z by k. So it becomes, so here in this z transform of cos n theta you just replace z as z by k. So we have z square by k square minus z by k into cos theta divided by, it is z square by k square minus 2 times of z by k into cos theta plus 1. So simplifying it further, k square is the LCM, and here z square will remain as it is minus zk into cos theta whole divided by, here also taking LCM in the denominator, LCM is k square once again, so z square will be there, and it is minus 2zk into cos theta plus 1. So this k square gets cancelled, and finally we have z square minus 2k, it is zk, it is zk into cos theta whole divided by z square minus 2zk cos theta plus 1. So this is the z transform of k raised to n into cos n. Similarly, we will find out z transform of k raised to n into sin n. So z transform of k raised to n into sin n theta will be obtained. Obviously this is also of the form k raised to n into un. Here un is sin n theta. So first we need to find out the z transform of sin n theta, and since we know that already we are having a z transform of sin theta as z sin theta divided by z square minus 2z cos theta plus 1. So here just we replace z as z by k in this answer. So we are having z by k into sin theta divided by z square by k square minus 2 into z by k into cos theta plus 1. So simplifying here, z by k as it is into sin theta divided by, taking a LCM here, obviously LCM is k square, and here it is z square minus 2z k into cos theta plus 1, and 1k cancel and 1k will remain here, that k will come to the numerator. So the answer will be zk into sin theta divided by z square minus 2zk into cos theta plus 1, and hence that is the z transform of k raised to n into sin n theta. Just now we derived the z transform of cos n theta as well as z transform of sin n theta. Now we will solve some problems based on these two formulas. Find the Z transform of So let us take this problem. Find the Z transform of 2n plus sine n pi by 4 plus 1. Obviously this problem can be solved by using these two formulas and also some basic formulas. So Z transform of 2n plus Z transform of, we will take Z transform for each of these terms. So sine n pi by 4 plus Z transform of 1. So this can be written as 2 times of, 2 is a constant, so I will take it out. So 2 times of Z transform of n plus Z transform of, I will write it as n into pi by 4 plus Z transform of 1. Now directly we write these answers. Already we are having the standard answers here. Z transform of n. Z transform of n is nothing but z divided by z minus 1 the whole square. Similarly, here we are having z transform of n pi by 4. So we can compare this problem with this sine n theta. So here in place of theta we are having pi by 4. Therefore according to the z transform of sine n theta, this expression become z into sine of pi by 4 divided by z square minus 2z into cos of pi by 4 plus 1. We just replacing theta as pi by 4 in this formula. And already we are having z transform of 1. Z transform of 1 is nothing but z divided by z minus 1. Simplifying it further, obviously this one as it is, no change in this first term. So 2z divided by z minus 1 the whole square plus, and since we know that sine pi by 4 is nothing but 1 by root 2. So we are having z divided by root 2 divided by z square minus 2 into z, and since cos pi by 4 is also 1 by root 2 plus 1, and third term also as it is. Simplifying it further, we have 2z z minus 1 as it is, the first term again, so plus z divided by, I will take this root 2 in the denominator, z square, and since we know that this 2 can be written as root 2 into root 2, so 1 root 2 1 root 2 cancel and remaining is root 2 into z plus 1 plus z divided by z minus 1 here. So this is the z transform of 2n plus sine n pi by 4 plus. Now let us take the next problem. Find the z transform of cos of n pi by 2 plus pi by 4. Find the z transform of cos of n pi by 2 plus pi by 4. So obviously this problem also can be solved by using these two formulas only, but before that we are going to use some trigonometric formula, that is cos a plus b. Cos a plus b is nothing but cos a cos b minus of sin a sin b. So using that formula, expanding this problem, so we have z transform of, it is cos of n pi by 4 into cos of pi by 4 minus sine of n pi by 2. Obviously here also it is 2 into sine of pi by 4. So simplifying, z transform of cos n pi by 2. Obviously cos n pi by 2 means we can compare that cos n pi by 2 with cos n theta. So obviously cos n into pi by 2. So here in place of theta we are having pi by 2. Therefore z transform of cos n theta is nothing but z square minus z into cos theta divided by z square minus 2z cos theta plus 1. So when you compare this cos with this function, we come to know that theta is pi by 2. So substituting theta as pi by 2 here, and remaining become z square minus z into cos of pi by 2 divided by z square minus 2z into cos of pi by 4 plus 1. And since we know that cos pi by 4 will be 1 by root 2 minus, again comparing this sine n pi by 2 with sine n theta, and since here also theta is pi by 2, therefore according to this formula it becomes z into sine pi by 2 divided by z square minus 2z into cos of pi by 2 plus 1 into sine pi by 4. Again sine pi by 4 is 1 by root 2, bracket completes. So here we just need to remove this z transform because already we have written the z transform. So this is nothing but 1 by root 2. I will take common, then we will simplify further. Cos pi by 2 will be 0, so 0 into anything will be 0, so remaining is only z square in the numerator, and since cos pi by 4 is 1 by root 2, so we will write it as z square minus 2z into 1 by root 2 plus 1 minus, again sin pi by 2 will be 1, so remaining is z divided by z square minus 2z into 1 by root 2 plus 1. So we have taken 1 by root 2 common. So simplifying further, we have 1 by root 2 common. So z square as it is divided by z square minus, and since there is 2 here, so this 2 can be written as root 2 into root 2. So 1 root 2, 1 root 2 cancel, 1 root 2 will remain here. So it is root 2 into z plus 1 minus z divided by z square. Here also same, we have root 2 into z plus 1. So this is z transform of cos n pi by 2 plus pi by 4.